Hi everyone and welcome to Sarah's AI Playground, and I'm Sarah, and today I'm excited to show you how to build a very first machine learning model using scikit-learn, and we'll be using the famous iris dataset to create a simple classification model. By the end of this tutorial, you will have a solid understanding of the basic steps involved in building and evaluating a machine learning model. So let's get started. First of all, we should simply log into our Google Colab. So I will just type the Google Colab Google here in the Google Home, and we'll just sign in here. Let's open Colab. Let's open a new notebook. So if you're new here, you just can simply create a new notebook by clicking this button. So yeah, let's create a new notebook here and wait a little bit. So here's our dashboard, like where we will create our first model. So here in this first cell, I'm not going to do this tutorial for the Google Colab, but if you want me to make some separate tutorial on this, just let me know. If it will be helpful, I will be glad to do one of this. So first, we should import library solvnet. Let's start by importing all the necessary Python libraries. We'll be using NumPy for numerical operations, pandas for data manipulation, scikit-learn for building our machine learning model, and etc. etc. Let's start just typing import NumPy. Sorry, NumPy. Because this is my first video here, I'm just a bit excited. So yeah, we can just simply click a tab here. So it just fill automatically here, but we don't need really the matplotlib. So I will just build it from here so we don't get confused. Next, we obviously need the scikit-learn datasets. Yeah, and we should import from a scikit-learn datasets, load iris, and yeah, you see it. Obviously, all init is already given by the AI, and it's really great that Google include this excellent feature. So we just click the tab. All init is already here, so we just move on with running the cell here. Waiting till all these libraries are loaded and imported. Great. It just took 2 seconds to do this. So then we click for a new code cell and move on with loading and exploring the dataset itself. So this step is actually doesn't involve to download any dataset from anywhere else. It's really great. We will just download it from, load it from scikit-learn itself. So I just type iris and load iris. As usual, everything is done for us. And the parentheses. So and we just load this data set and the parameters here. As you go on, the Colab will fill by itself, like it's still a copilot. It will help you anyway, yeah. PD, it's actually our data frame. So we have the X, and I'll just click the tab. So and the here actually in the data frame hat, now we just need to include the title of this column, the name of this column, species. and print df and hat. Yeah, I'm just done with loading this data set. So let's quickly run this cell and see what we get. As you can see, we have 4 feature columns representing the measurements and 1 target column representing the species of the iris flowers. We move on and split this data set. Now we'll split the data set into training and testing sets. This helps us evaluate our model's performance on unseen data. So we have from one data set both training and testing sets. It's very convenient. So you don't have any other data from anywhere else. You don't have to search for something. We will just use our own one data set. It's actually the most comfortable way to both train and test. So if you don't have any other data set in any other project, you can just simply split one data set into some portions, yeah, and leave some portion for the testing purposes. So the X train, X test, Y train, Y test, train test split. Yeah, actually everything that we need is already filled for us. So as you can see, because the iris dataset and the work with a machine learning classification for this dataset is one of the most popular, Google Colab already knows the flow, so it will not be very confusing for you to move on. It will just give you the way by itself. It will just guide you. So we just now split the data set. As you can see, the test size is 0.2. It means 20% of our data set is gone to the testing. So the next step we do is we process the data. For this, why do we preprocess? It's very important to standardize the features to ensure that all features contribute equally to the result. So in some cases, you may have the data that does not really match the algorithm that we are going to use. So for this case, we have to transform this data into something else that will actually suit our algorithm. So in this case, we will do the same. We will use the scalar and standard scalar, and again it fill in everything for us. So I just quickly click the tab and all things are done. This step helps to improve the model's performance, ensuring that all features are on the same scale. So I quickly run the cell. By the way, we can just click Shift and Enter to quickly run the cell without need to click on the button right here. Yeah, it's very convenient. So the next step we do is actually training the model, and I'm very excited to do this with you. With our data preprocessed, we can now train a logistic regression model. Logistic regression is simply a powerful algorithm for the classification. So now we are just classifying, yeah, the flowers, iris flowers. So we will be using this algorithm. Actually, you should look at your data set. Yeah, there may be many options for you on what algorithm to choose. And we actually have to see what will be our use case and for what purposes this model will serve. And in our case, logistic regression is the best fit model. I'm an algorithm. So we just, oh my God, click here. Okay, yeah, sorry. And model and logistic regression. And here we just have the function, and here we do the fits. X train scaled and the Y train. Actually, I could just uh, tap the tap button. Yeah, that's great. So let's move on. Yeah, it's done. Actually, most of the machine learning models take a few minutes or seconds to fit the model, and it's very powerful and very speedy. Yeah, this is what I love in machine learning algorithm models. Algorithms itself. Okay, next step is making predictions. So let's see. Let's use our trained model to make predictions on the test set. Uh, why prediction? Model predict. Here we go, a task for our model. Test scaled. The scaled version of the test set. Let's run it. Okay, we're done. And evaluation. I will just quickly um type the tab and let's see the accuracy. Oh, great! It's 100%, of course, because we had a simple task and uh our data set was not so big. We got this very good result. Actually, um, in some in most of the cases, while we are using and testing your model's accuracy, it's not very good to get 100% accuracy. Yeah, it means that something is wrong. Maybe your data set was very limited, and your model just learned all of it. Yeah, and that's why it's performing like this. So I'm just going to run the cell with the report, the classification report, and let's see this. Yeah, here we got the name classification report is not defined. So I guess the problem is we didn't actually import from here the classification report. So we just click the tab and run the cell again and try to run the cell again. Great. So we can see the amazing results. Yeah. Okay. Great. Uh, Actually, we got our model right now, and we've successfully built and evaluated this simple classification model using scikit-learn. We've covered important libraries. You already know how to use it. Loading and exploring the dataset, splitting the data, processing it, training the model, making predictions, evaluating the model. And as next steps, you can try experimenting with different models or tuning hyperparameters to improve performance. Um, so yeah, I hope this video was helpful for you. Thank you for watching. And if you found this tutorial helpful, please give it a thumbs up. And don't forget to subscribe to Sarah's Playground for more machine learning content. And if you have any suggestions, questions, and anything to say, just leave a comment below and see you in the next video. Thank you so much. Bye.